Всем привет!
Hello guys, HackAtom RU back on air. Another workshop of the series, another useful one for you. And it's not going to be a long one today, so feel free to tune in, ask questions to the speaker. Yuiry Savchecnko is the speaker of the day. He's going to be talking about using CosmWasm contracts in creating Ethereum wormhole bridge. So some use cases, the background of the project, how they worked it, the pitfalls they encountered. Yuiry, can you hear me? Can you hear us? Yes, awesome audibility. Thank you. Hey, everyone. Great, the floor is yours then. Fire away. Thank you. Thank you once again. Hello, everyone. Today, I'm going to be talking about the practical application of CosmWasm, the practical use cases in blockchain, in Terra blockchain. The way we added Terra support to the wormhole bridge. So, as for the information, or as for the knowledge you're required to have, basic understanding of Ethereum and CosmWasm smart contracts. That's it. Ethereum, CosmWasm, SCs, that's all you need to know. Ethereum is really known by pretty much everyone. So it doesn't require special expertise or special profound knowledge to understand my presentation. Right, so let's keep rolling. A couple words about Terra. Terra proper is Cosmos zone. It is dealing with financial services, stable coins, etc. All the other kinds of useful gizmos in fintech. An important thing, they've added CosmWasm earlier. I mean, before the version that's available right now. Right now, it's too late to update. They will be updating in the future. However, these examples, the things we've been working on is CosmWasm version 0.10. So some screenshots might show you various weird syntax that's not there any longer. So just bear in mind that the earlier version was used to put it together. But everything else works similarly. As for the wormhole bridge, the wormhole bridge has been developed by the Certus1 team. That's the GitHub link. It's supposed to bridge transfers. It was built for transfers between Ethereum and Solana. The bridge itself was written so it can be extended to other blockchains in the future. And basically, Terra is the first blockchain to be added on top of those initial, the original Ethereum and Solana support. Right, a few words about the wormhole architecture, the bridge itself. So, if you've seen a bridge, you've seen them all. You've just seen one, seen them all. There's always an entity that launches assets on one blockchain and retrieves it on the other blockchain. The fine thing about this bridge is that there are the guardians entity, the so-called guardians. That's an entity. They form their own consensus off-chain. They monitor transfers on one blockchain. They see locked assets, and they monitor the situation. They reach consensus, and then the VAA gets sent to Solana contract. Verifiable action approval. Basically, yeah, that's a verifiable action approval. Nothing to explain here. It's a command to the receiving side that comes with signatures of the guardians. That's it. So VAA comes from one blockchain. It is verified by the guardians, and with the signatures, it gets sent to the Solana contract. Then the contract mints the wrapped tokens. Right, rolling on. So our team started working on the Terra part when everything was more or less ready for Ethereum and for Solana. And the question that we had is, what do we port? Because we were supposed to port one of the contracts. Which one? Let me tell you a few words about blockchain, Ethereum, and Solana. Well, we're getting a bit farther away from the original topic, but it's important to understand that Cosmos is the blockchain of blockchains. It's important to understand the difference between these various blockchains out there. Now, in the context, in the CosmWasm context, despite the fact that Solana development is all about Rust language, the Solidity standard, we went for Ethereum nonetheless as a platform that we're going to port from, particularly for the reason that regardless of all the difference of Cosmos, its architecture is closer to Ethereum than Solana. Solana has a whole bunch of particular features that I'm not going to be talking about right now. So this is the last time I've mentioned them anyway. But yeah, interesting topics out there as well. So porting from Ethereum to CosmWasm. Now it's going to be the focus ever since in the presentation. As DeFi services migrate to Cosmos, so yeah, Cosmos, that will be a typical task, conventional task, right? So let me tell you right off the bat that possibly somebody will find these missions or these objectives, these tasks trivial, those who've seen Cosmos from the inside, but they will get more complicated as we proceed. The first objective is to create a wrapped CW20 contract. What is that? That means creation of a token, Cosmos-based, that is going to bear additional information about the original token in Ethereum. So basically, the task right now is to put together a system where ERC20 token from Ethereum could be ported to Terra, could be placed to Terra. And essentially, it's very simple. I mean, so in the future, you might be seeing more of this, doing more of this, but basically, you need to use a CW20-based crate. We had to customize the minting and burning of tokens. That depends on the business task, but yeah, we had to do that. We customized the initialization message, the init message with token information, and we throw in additional query messages, query message types, so that this information could be transmitted or picked up from the contract. So the first task is very simple, very elegant, very straightforward. So here's a resource for you. This is the crate that we've used, this CW20 base. Everything is ready for you. Making tokens is easy and painless. Just one more intricate thing here. Owing to the fact that 0.10 Cosmos was used, we had to use the more recent version, 0.22 rather than 0.50. This is the last version. We had to use 0.22 for Terra. That's the only intricate bit about this. Things get trickier as we move forward. To confirm to validate the identity of the guardian, for the purposes of validation, guardians sign the contracts with the signatures. That's SCCP 256 K1. That's the typical signatures that you've seen on Ethereum. They are hardwired into the bridge architecture. There's no way we can bypass that. So we had to verify smart contracts in CosmWasm using this signature verification method. The approach to that, yeah, just a few words about what it means. Ultimately, I've mentioned briefly. So we're supposed to make a Callback hash of the data that is passed on, and then we're supposed to receive the public key, to recover the public key from the signature and compare it against the one the guardian sent. Essentially, if you know Solidity, that's Callback 256 and EC recover. Well, we had to make sure that these functions can be triggered directly from the bridge. And well, luckily, was a happy coincidence. We didn't have to do much to get there. Just to add the dependencies in the library that do that. Those libraries are available. But the fact that it worked out for you does not suggest that it's going to work out for everyone out there, for all of you guys. So if you want to make these things, so we'll check the gas spend. Test and see if gas spend is within allowed limits. On Terra, we were very well within the margin of tolerance for gas. It doesn't have that much, that high requirements. Others might have higher requirements for gas. So guys, if you're implementing these cryptography bits by third-party libs, make sure you test that. Test that for the gas spend. Right, a part of the code, how these libraries are used. Many scary things out there, like error, contract error, but these are custom errors of our contract. What is essentially made? What is essentially done? The smart contract picks up the signature from the command and the recovery ID, after which the signature is created, the recoverable signature is created. The public key is retrieved from that one. The public key is then compared to the personal key of the guardians. Everything is fine. If everything is fine, and that's right there. Otherwise, it returns an error. If key is equal, everything is fine. So it's not, again, not that much cumbersome a task, but yeah, it was more interesting than the first one, right? Calling other contracts. That's an obvious thing for some of you, granted, but well, basic examples don't showcase that. And it's a very important thing. It's a very important thing to make sure that your contracts can work with others. So we're stronger when we're together. So everything here is split into two things. First thing is requesting information, requesting the data from other contracts. This is done by the query method. A query is made with wasm query smart type, and the message is passed. The message that you want to get. It's just an empty request in this case, just an empty message without any params. The second bit is the messages proper. Messages, the kind of messages you want to send once the performance of the contract has been completed. So yeah, just a final message once the contract has been done, like, okay, I want to send this contract as well. WASM execute, WASM message execute the address, which message to send, and that's it. Everything is nice and fine. Well, I will talk about this important thing I was going to mention later. Right now, the important thing to keep in mind when porting your code from Solidity to CosmWasm is that these calls, the messages can be invoked only at the end of your smart contract. So this will affect the logic a bit. To which extent can Solidity can call another contract? It will change the state of the contract. It will come back, and then depending on whether it worked or not, you will take things as they are. In CosmWasm, it's not going to fly that way. You will have to change the logic in such a way that third-party calls is the last thing you do in your contract. So all these checks need to happen before, need to happen earlier. Yeah, so I might as well reserve this for the later part of the story. Now, another interesting thing is creating new contract instances. In this case, we will face the difference in the architecture of Ethereum and Cosmos in terms of handling smart contracts. Yeah, creation of new contract instances. Maybe you will have to make a contract factory that will be busy generating just that, new contracts for your users. Now, how does that? Well, just a rank and file deploy of contracts on Ethereum, how Ethereum contracts are created. The code is deployed, the address is received. There is step two. There is no step two. Each time when the contract is created, you deploy the code anew once again. The CosmWasm works a bit differently. Deployment of Cosmos contracts is different. You deploy the code, you get the code ID, and then that code ID is used to create a contract instance, another instance. So the upside is clear. The big upside, the big one at that, is that you don't get the duplication of the contract code across the blockchain network. Those ERC20 tokens, which are basically the same, and they get deployed from scratch every time. That overloads the stack significantly. Well, in this case, you just run an instance of the same code without putting too much extra stuff, redundant stuff in there. So on Ethereum, people understand that the situation I've mentioned is quite adverse. It's bad, and it needs to be fixed somehow. There is a proxy pattern that works similarly to the Cosmos contract. Particularly, there is a reference implementation, so some code that somebody uploaded, and to make its copy, basically an instance, a new instance, the minimal proxy is deployed. What that stands for is essentially that there's a contract that receives the queries to itself. I mean, it intercepts the queries, and it runs the code in a different contract, but within its context. It works a bit different on the inside, but on the outside, it looks a lot like CosmWasm logic, right? So how do you create an instance? It's damn simple. So you just, well, getting back to the Cosmos. It's damn simple. So you just need to return the message, WASM MSG instantiate with the code ID and the initial message initialization params. So I've chopped this code a bit because this is a spoiler alert for the next bit, for the next task. You'll get to see the code, the whole of it. Promise. Right? No, wait. I think I've already told this stuff. So let's just imagine this is the continuation of the topic, because I've listed quite a few. I've mentioned quite a few. There is such thing as deterministic addresses on Ethereum. You might correct me if I'm wrong, if my knowledge of Ethereum my knowledge of Cosmos is a bit rusty. Maybe Cosmos have these things, the deterministic addresses. Maybe not. That means that a deterministic address gives a specific address of the contract before we deploy it. It will derive from some seeds, from some seed data. It will be derived, and so it will be known for a fact in the future, for the future. What's important in the wormhole context? Because whenever you create new wrapped tokens, tokens that will be received on the recipient blockchain, the smart contract is supposed to know the address of that token, so that the same token can be reused for outgoing transfers. How it's done on Ethereum, and how Ethereum does it. There is this create2 that receives the seed and returns the address, the deterministic address. This is how proxies are listed on Ethereum. This is the proxy pattern, by the way, if you're interested. This is it. This is the contract code out there. After this, the newly received contract address gets stored to state somehow, and it will be used. Right here is saved, stored, and it will be used for future transfers. Now, what is the problem in CosmWasm? As mentioned before, the calls of third-party contracts, including the deploy. Let me take you back a few slides. Deploy, instantiate. It's instantiate in this case. because deployment envisages code, whereas the code is already in the state. Instantiate is the message that is sent at the completion of your contract, once the contract has been done. What it means that the outcomes will not be stored anywhere. The execution outcomes will not be saved, and the address of the new contract will be unknown, will remain unknown. Yeah, that's the stuff I've been describing. No deterministic instance address generation. The messages do not return values. And additionally, on top of that, on solidity, this logic is often seen. You making a new contract and you mint some tokens. In this case, we cannot do that on CosmWasm. The reason, like I said, we're doing this at the very end of contract execution. There's nothing that we can do afterwards. So how do you bypass these problems? The problems with calling the challenge of doing something new, doing something in the new contract. It's done quite simply. You just expand the init message. So once the new token has been created, we needed to do something else. And basically, we just feed this information, feed this on as one of the parameters in the init message. It's an option init mint. It might not be there. It might be there. If it's there, it will get executed. The contract will get initialized, and it will run the command that we've thrown in there. Right. So how do we determine the address of the new contract? How do we know it for a fact beforehand? There's no way we can. I mean, there's no.
Мы можем сделать хуки, да, это у меня такой капитан Хук. Что это значит? Это значит новый задеплойный контракт, вызвать message в том.
Right, the newly deployed contract, we can trigger the message in the one that deployed it, and in that case, thereby we will store the information that we want. The sender of the message that is sent to the triggering calling contract, it will be the newly created contract. So here's how it works. This is the layout, the setup. There is a parent contract, the calling.
Deploy, да, instantiate. Так правильнее было. Вот.
Actually, it should have said instantiates the new contract, but okay, I wrote deployed guild as charged, and it sends the init message with a hook to the child contract. The child contract gets initialized, code initialization is performed, and at the end, the hook message is added to the list of messages that it sends back to the parent. Essentially, the blockchain calls again the parent contract. So it's kind of a loop calling. So be careful, definitely. Don't do this time and time again, because you will run out of gas and nothing's going to work. So how does it look in the code? That's the code appearance. This is the init message for the contract that is being created. And it has one of the parameters. It's init hook.
Контракту вызвать
hook is already been serialized, and where to send it? Which contract gets which message? That's the way it looks in the calling code. That's it. So what have I done here? Using callbacks. That's the way this hook is triggered from the newly created contract. Right. So this is how it's created. CosmWasm might execute. The address, the message. The contract doesn't even have to know what message that is. Everything is inside. So the rest is handled by the calling contract. So like it's not my message, I'm just passing it on. I serve as a messenger. That's about it. Captain Hook again. That's the end of it. So this has been little bit of journey, a small journey that we've reinforced and that we've been able to surpass. I mean, we've done that. Ready for your questions now. Thank you, great. Looking at the questions, there don't seem to be any at the time in the Russian chat. And hooks, yeah, somebody liked that image, Captain Hook. And our text with the hackers also seems to be dormant. I believe everybody is pretty tired from the workshop series. Yeah, I get that. Right, so the people will watch it afterwards. There's valuable info about the bridges. I think that if there are questions coming up at a later stage, well, Yuiry, I'll just get in touch with you somehow to ask your replies. At this point, thank you guys very much. Looking forward to seeing you tomorrow. The closing one is tomorrow.
Хакерами. Если хотите, если у вас есть
about to end. Talk to the hackers here if you feel like, if you have questions. But I believe that the projects must be around the time of completion. So you should near the completion of your projects. So dev post, log in, there's still some time to participate. There's still some time to reap all those bounties. See you tomorrow, guys. Until next time, tomorrow. See you tomorrow.